Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, the most common mistake people make the first time they set up an agent, cramming everything into one giant instruction file, and the three-layer model that fixes it.
Give me the three things people wrongly pile together, make it concrete.
Take 3 real requests. Always use our commit style. Here's how to fill our compliance PDF. And write this file to disk. Feels like all 3 go in one place. They absolutely don't. The first is a standing rule. The second is a specialized procedure you only need sometimes. The third is an action. 3 different mechanisms, 3 different loading behaviors, 3 different costs.
So name the 3 layers cleanly.
Instructions, knowledge, action. Agents.md is always on instructions. A skill is on-demand knowledge, the model loads itself. And a tool call is a runtime action. The one-liner I'd carry through the whole thing. Instructions you always carry. A manual you pull off the shelf when it's relevant. And a button you press to make something happen.
Start with Agents.md. What is it really?
It's a plain Markdown file at the root of your repo. They call it a README for agents. It complements your human README. It holds the agent-facing detail, the build steps, the tests, the conventions that would just clutter the README. And it's loaded every single session. 2 properties define it. And the first is that it's vendor neutral.
Vendor neutral meaning what? It's not locked to one tool.
Right. OpenAI introduced it. But it's now read by 20 plus agents. Cursor, Gemini CLI, Copilot, and more across 60,000 plus open source projects. And in December 2025, it became a founding project of the Linux Foundation's Agentic AI Foundation, which is about as concrete as vendor neutral gets. The proprietary cousins, Claude's.md, Cursor's rules, are the same idea under a different file name.
Here's the trap I'd fall into. I write never force push to main in that file. That's enforced now, right?
And that's the nuance that bites people. No, these files are context, not enforced configuration. The docs say it plainly. There's no guarantee of strict compliance. It shapes behavior. It doesn't guarantee it. The model can still wander off. If you need a hard block, never run a force push. That's a different layer entirely. A hook, a permission rule, not a sentence in Markdown.
Okay, layer 2, skills. You said the model loads them itself. That's the part one want to understand.
That's the crux. And it's what separates a skill from agents.md. A skill is a folder with a skill.md file, a packaged procedure. Its front matter has exactly 2 required fields, a name and a description. And the single most important authoring rule is that the description must say both what the skill does and when to use it. Because the description is the only thing the model sees at first. And it's what the model matches the task against to decide whether to fire it.
So nobody flips a switch. The model reads the description, judges the task relevant, and pulls the full thing in by itself.
Exactly. Model invoked, not human picked. And the mechanism that makes that cheap is progressive disclosure. 3 levels. Level 1, just the name and description. Roughly 100 tokens. Always loaded so the model knows the skill exists. Level 2, the full body. Under 5,000 tokens. Loads only when the skill triggers. Level 3, bundled scripts and files. Read or run only as needed.
Wait, that kills the obvious objection. Won't installing 30 skills bloat my context window?
It's the misconception the whole design refutes. 30 skills cost 30 tiny descriptions until one fires. The big body only loads on demand. And here's the genuinely clever bit. A bundled script source never enters context at all. The model runs it via the shell, and only its output comes back. So you can attach something huge and pay almost nothing until the moment you actually use it.
Layer 3 is tool calls, which I half know, but nail the one distinction for me.
The one that trips everyone. The model does not run the function. Mid-generation, it decides it needs a capability and emits a structured request. A tool name plus JSO arguments. That's all it does. Your application code or the provider's infrastructure actually executes it and feeds the result back. Then the model continues. A request, not an execution.
And where does MCP sit in this? People talk about it like it's a separate thing from tool calling.
It's the same primitive, just standardized. So any client can discover and invoke tools exposed by any server. MCP is a different thing from tool calling is a misconception. MCP just standardizes how external servers expose those calls, and it actually sharpens the whole who decides access. In MCP, tools are model controlled. The model chooses to call them. Resources are application controlled. The app supplies the data. Prompts are user controlled. The user picks the template.
So let me land the insight because now the whole thing composes. These aren't competitors. They stack and each points down to the one below.
You've got it exactly. Agents.md sets the standing rules and can point to a skill. For this, use that skill. A skill is the just-in-time playbook, and its body commonly orchestrates tools. Call read file, then write file. And tools are the hands at the bottom that both of the above ultimately drive. 3 layers, 1 stack.
And there's a neat way to hear the failure modes, isn't there?
There is. If your instruction file is 3000 lines, you've stuffed skills worth of procedures into the always-on layer. Move them out. If you're pasting the same procedure into chat every few days, that's a skill waiting to be written. And if the agent knows what to do but can't actually make the change, you're just missing a tool.
So the one sentence?
Always-on instructions, on-demand knowledge, runtime actions. Match each thing you want the agent to know or do to the right layer, and you stop fighting your own context window.
Right layer, right cost. That's the Datarekha audio guide. See you in the next one.